2.
Wait, what is it called though?
Oh, auto.
So what is it?
6, 7, 8.
6, 7, 8, what?
6, 1, 2.
6, 1, 2.
5,
5, 8.
5, 8, 6, 2.
No, one.
Did I lose my video? Oh, here we are.
My book is on the back. Text you.
Your work, she did.
For lesson 9?
Yes, she did. But if you haven't, go ahead and throw it up there. But I think I already graded yours.
And now you gotta wait. And when you put my glasses on, take it since I missed this car one time, you know. I think you know me well enough that paper's already gone in my.
Yeah, no, I think that's probably the case.
Remember when
That would be smart.
I come up to the door and he was not talking to me.
Wasn't this one a turn? Turn
I
camera.
hope they start soon.
Somebody's singing. Jocelyn is singing.
It works. Dang it. Can I?
Oh, this camera is stuck.
Wait, this is the body. I think I saw.
This camera won't do
I
it.
can't remember. Wait, what? They're hackers. They're hackers.
Hey, look, we're gonna sit in here today. I can make this go. This is annoying. My camera won't. Look, what's wrong with my
That's what
camera?
people tell me. They're not hackers. I want you to know that you were in. They're not imposters. That's a hacker. Tell me if they won straight away from their.
There it goes. Flip. Please flip. There. That took all freaking.
My gosh, yes, and you can change it now, not too crappy. Oh, that's it. Sorry. I thought it would work because one time. Oh my God,
We're gonna wait here.
freaking cats. Oh my gosh, that's a lot of cats. I don't get any cats. I'm like, I just want to stop. Yeah, I don't kill them though, especially I don't kill them from.
Okay, give me about 2 minutes, guys. I'm gonna let this get baby.
Always.
There it goes. I don't see Senya yet.
What is? Wiping the car. No, it's not. It's calibrating distributors. Now,
Hey, Miss Jocelyn, how you doing?
it's even.
Good.
All right. Okay, give me about 1 minute. You following me now? Okay. I need your help. Everywhere I go, we're gonna teach. What do you know about chemical reactions, Oswald? Anything? I don't.
No, he doesn't get my rock chemical reaction. Hey, Ozzy! Yeah, did you hear something? You can try burning a spur to see what chemical reaction that would be. What? They're coming out with it. I can wait, and I'm an imposter.
Drew, toss me Zilla so I can have one.
Zilla?
That worked. Thank you. Don't toss over that. Look, Drew, go put that in the kitchen. You don't need to grape juice out, for goodness sake.
Yes, no.
All right.
I'll just stand still.
So last week, Kai said something about coming back, so I don't know if that means we get travel or not. Hang on, I have messages. Maybe one of these is Sonia.
Miss Annie,
Yes, ma'am.
I was so excited for class that today, last night I woke up twice in the middle of the night. One at like 1 o'clock in the morning, and then at like 6:16 in the morning.
Wow, you were super excited about today, huh?
Yes.
Geez, should I take that as a compliment?
Yes.
Okay.
Maybe.
Then
No.
maybe you don't know. That's
don't know.
right. All right, let me shoot, hang on. I'm trying to send something to Sonia real quick. She needs a meeting ID. So hold on. 1 second. Why did that open? That's not what I clicked. I clicked this. I can't see it because of that. Okay, go away, go away. Too many windows are popping up. Did he lick your eyeball? That's awesome. Too many little things on my screen to get at what I want to get at here.
He's my spirit
Oh, come on. Oh, come on. Well, how do I get it from here? Shoot. Okay. Hello. Whoop. No. Leave. Cancel, leave. Hey, Sky. Can y'all make room for Sky over there? Okay, hold on. Okay, I'm sending this to Sonia. Okay. Sonia should be on in 1 second, and I think that's everybody. So Sky's here, so we're good to go. All right, so today we're going to be doing chemical reactions, and you guys are extra lucky because you get like double labs. So what we're going to do today, a couple things. We're going to go outside after we finished the lecture part of our lesson, and we have a couple little experiments to run out there just for fun, just little ones that everybody should be able to participate in. And then for today's lab, we're going to film the lab live, and I'm not going to film like the whole thing. I'm going to come in and get little bits of you guys doing pieces of the lab, and I'm going to edit it in with all of the other slides and stuff that I usually put in a lab. So you guys will, it'll be great for the kids that aren't here because they'll get to see you too. Oh, you left all your stuff up there? What? Yeah, that'd be good. Okay, so I'm gonna put my screen up here for you guys. And hopefully this should be kind of a quick lesson before we get outside and get to do the fun stuff. Yeah. So I'm gonna squash this up in this corner. So if you have your flat books or anything else that might help you get answers as we come to questions, that would probably be helpful. But if you don't, not the end of the world. So we have two main types of changes that we were talking about and reactions that we were talking about in this last lesson, right? Physical changes and chemical changes. So we have this here, a change of state or form without a change in chemical composition. What would we be talking about there? Is that going to be a physical or a chemical change?
Physical.
That's right. That's going to be a physical change.
It's changing like the thing is, but it's still the same substance.
Mm-hmm. There's a typo there. Look, it should say one or more substances are altered into one or more different substances. What kind of reaction is that?
Chemical.
That one's going to be chemical. All right. So what we got here in the physical change is, can you tell what that is? What's happening there?
Boom.
In the physical, with the physical change, what's going on there?
No.
Yeah, it's melting, right? So it's just changing state. And how about the chemical reaction? That's actually what happens when potassium hits water.
Ooh.
Isn't that fun? And you remember what color potassium is when you burn it? Do you remember? It's that lilac color. So there it is again, that purpley color. That's pretty. I like it. I was actually trying to clean some crucibles this week, and the chemical that you clean them with, the compound that you clean them with, contains potassium. So occasionally little bits of it would fall out of the crucible and land in my flame, and I kept getting a purple flame. It was kind of fun. All right, here. So signs of chemical changes. Does anybody remember what they are? I think your book lists 5, but there are more than 5. So how about this one? What do we think this one is? What might this picture represent?
Colored water.
It is color. What's the
Different chemical, different like chemical or physical changes.
yeah? What does color have to do? Can color be a sign of a chemical change? A color change? Can that be a sign? Yes, absolutely. So a change in color is a sign of a chemical change. A physical change isn't going to cause a change in color, really. So it might look a little different. Something melted might look a slightly different color, but that has more to do with density usually than anything else. So we're going to do our lab today. It's going to be about a color change, and one of the little experiments we're going to do outside is also going to be about a color change. So you're going to get to see that twice today. Now, how about this one? What do we think this represents? Oh, hang on, let me put some
Stinky shoes.
stinky shoes. What might stinky shoes have to do with chemical changes?
Represents my face.
Represent-
What is odorless? It reminds me of the stuff in the air.
That's right. Yeah. Okay. So actually, your perspiration when you sweat. Morning, Senya. It is odorless, but the reason that you stink when you sweat has to do with the bacteria that live on your body undergoing certain chemical changes as they digest all the yumminess that you've got going for them. Yeah. So the production of an odor is a sign of a chemical change. So Senya, we've noted that a change in color is a sign of a chemical change, and a production of odor is a sign of a chemical change.
Where are
Senya and Jocelyn, I mailed your second 9 weeks lab kits yesterday, and they said 2 to 3 days. So I expect you'll get them by the end of the weekend.
Okay.
And they're full of cool stuff.
I got what lab are we on this week again? What lesson are
10.
we on this?
10. So change in color and production of an odor. All right, how about this one? Does anybody know what this might represent?
I don't know, but
Yeah,
it's
that would
pretty.
be-
Very pretty.
Mhm. It is very pretty. Yeah. Yeah, it's a kind of chemical change, but these are all signs of chemical changes. What sign might this be?
Color.
It's formation of a precipitate. Do you remember reading about that?
Yeah, that was.
So yeah, usually it is some kind of a crystal that forms inside suddenly really fast. We're going to do that today too when we go outside and do our little mini experiments for fun.
Can we make acid?
Hmm?
Can we make acid?
We're not making acid today, but we're going to deal with acids and bases in a couple
I
weeks.
want to make like an acid strong enough to like melt through like pans.
I have an acid like that, but we're not gonna make it, but I have one like that. Yeah, Lily's terrified. She's like, what? No, don't do that.
Like this one acid that I can melt pretty much anything in the world.
Mm.
Well, then how do you store it? I think you store it in itself or something.
Yeah.
It's something super strong. Well,
Yep.
wait, if you're gonna store it in itself, like a solid version of itself, then how does a solid version of itself not melt through the table and into the earth's core? It's like ridiculously strong, right? There's only like one thing that can hold it. Something.
Well, let's go back to this. And we can debate safe storage of acid later, but we'll go on to this.
Oh,
So formation
Dan-
of a precipitate.
Back to science and then to acid immediately.
Mm-hmm. Yep.
Hey, Danny.
So what might this one be?
What?
I can go to fires instead.
Does anybody want to? Anybody want to guess what this picture might represent?
I don't know.
These are all signs of chemical changes.
Yeah, sign. On the back.
What sign might this be? What's in the beaker in the front? Can you tell what that is?
Green liquid.
Green liquid, and what's in the green liquid?
I don't know.
Thermometer.
It's a thermometer. So what might this represent?
Heat. Endothermic.
Hot liquid.
A change
Hot or
in
cold
temperature.
temperature.
There you go. Good job. So a change in temperature is a sign of a chemical change, and we've got that to represent.
Chemical reaction.
Right. Well, it could be endothermic. We don't know yet.
True.
So we'll look at that in a second. So there are some changes. Now, what might this one be? One more.
Carbonation.
Hey, Danny.
Not, yes?
Are we on any like particular page or anything?
Not at the moment. We're just kind of going over in general. Your book listed some signs of chemical changes. So we're going over them.
Chlorine and water.
So this is, what do these look like to you guys?
Yeah, it looks like a little-
Bubbles?
Bubbles, bubbles. Who said bubbles? Was that Senya or Jocelyn? Senya. Okay,
Senya.
bubbles. So
I didn't say anything.
there you go. So what do bubbles represent?
Something dissolving in water.
Air.
Evolution of a gas. So sometimes you get a gas, right? You get an evolution of a gas when you have a chemical change. Yeah, Cole just smashed stuff back there. So yeah, evolution of a gas, color change, formation of a precipitate. What else did we say? Change in temperature and change in color. Your book did not list, however, how about light production? You can have light production without a change in temperature. They call it cool light, and that can occur as a sign of a chemical change. And there are a couple of other things, but that's an obvious one that I was like, hello. So now we get to talk about the different aspects of the components in a chemical change. So we have two main, 10. So we have two main parts of our chemical reaction. So we have our reactants, all right? These are our reactants. And when you have reactants, they're the substance that takes part in and undergoes the change during the reaction. So they're what you start with, okay? You start with the reactants because they're gonna react, all right? And the reactants also are usually located to the left of the arrow in a written chemical reaction. So look at this, guys. When you write out a chemical reaction and you put in the chemical formulas for, you guys listening? When you put in the chemical formulas for the different chemicals involved, you're always going to put the reactants on the left. And then there's an arrow. Do you see the arrow? And then what's on the other side?
Product.
Products. Good. Okay. So the arrow basically represents the change. And sometimes things are written above the arrow or below it, and it'll say things like heat or light. And that's where you put, are you guys okay over there? Drew, are you good?
We're listening at something.
Okay. So when you get the, sometimes people put the sign of the chemical change or what's happening during the chemical change on that arrow. So for example, very often you'll see the reaction for photosynthesis, okay? And people will put that arrow and they'll write on it sunlight. Like sunlight is the energy involved in that case. So your reactants always go on the left and your products always go on the right. So you can kind of read the arrow as changes into. So you could write like hydrogen and oxygen changes into water, right? So when you have products, they're going to be obviously the substance that is formed as a result of the chemical reaction. So your products are going to be on the right side of the arrow, like we just saw, right? Right there. So that's going to be what you form. So every chemical reaction is going to have both reactants and products. Sometimes it'll be really obvious what those things are, and other times it won't be. Like sometimes, for example, think about rusting. Okay, rusting is a chemical reaction. It's really obvious that the metal is involved, right? You got iron's involved. But what's one of the other main components of rusting? Do you know what causes rust?
No.
Well, yeah, rust is oxidation of the iron, so it has to do with oxygen, but you don't see the oxygen. Yeah, it ends up being ferrous oxide, but you don't see the oxygen, right? Because it's a
Rain?
gas and it's all around you and you don't notice it, but
Rain?
it's part of the reaction. Yeah, rain, water and all that. Yeah, that all helps. Now, another thing to consider with reaction is something called a catalyst. And we're going to talk about that today because one of the reactions we're going to do outside is going to have a catalyst. So a catalyst is something that speeds up a reaction. And usually it's an enzyme. So you'll hear about enzymes. You hear about enzymes a lot when you talk about health. Like people will say, oh, you need better digestive enzymes. You ever heard anybody say that? Or digestive enzymes. Yeah, they speed up the chemical reactions involved in your digestion process. So you have enzymes in your body. There are enzymes in nature everywhere, and often they could be a catalyst and they speed up a reaction. Now, one of the reactions we're going to cause today involves a catalyst that's actually called catalase, go figure, because it's pretty common. And it exists, one of the things it exists in is yeast. So we're using yeast in a reaction today because what it's going to do is speed up the reaction.
My screen went black. Can you still see me?
I can't see your face, but I see your name.
I think you might have turned off.
Yeah, you might have bumped. There you go. Hello.
Yeah.
There she is. She is back. All right, so endothermic and exothermic. So Alec mentioned this. All right, now these are two main types of energy release in energy release or energy absorption in reactions. So an endothermic reaction, I thought this was a cool picture. I don't know that it's the product of an endothermic reaction, but look in that picture. Do you see the tree? That tree grew in there on ice. That's really cool.
That's pretty.
I know. How do you make that happen? So an endothermic reaction, and this is kind of, you have to think about it almost kind of backwards is the best way to describe it. So an endothermic reaction is going to absorb energy from heat. And if that's going to make it feel cold, you might think that absorbing energy would make something feel warm. Like you would think, well, if I put my hand on a heater and bring my hand back, it's going to be warm because it absorbed that heat. But the reaction itself, when you absorb the energy in the form of heat, it makes it feel cold. And that happens when chemical bonds break. So in order to break bonds, you have to absorb energy. It's going to take energy to break the bonds. And then that is going to make it feel cold. What are you looking at? Jules keeps looking over here and laughing. What are you looking at? Oh, you guys are so silly. So now look at this one. Exothermic. So if an endothermic absorbs the energy, what's an exothermic do?
It releases
energy in the form of heat. And if endothermic brings the heat in and then it feels cold. Exothermic puts the heat out, so then it feels warm. Right. But if you're breaking bonds with endothermic reactions, then what are you doing with exothermic reactions?
You're
forming them. Right. Senya drew it. It's beautiful. What is it, Senya? It's just scribbling on the screen. Yes, Miss Eleanor, do you have a question?
I was trying to get a hair off.
Oh, is it? What'd you say, Eleanor?
You know that tree thing?
Mhm.
You can actually get a crystal and you can like buy a kit of that, except it's not all the way up. It's like this builds and you pour solution on it.
It's a catalyst that makes the tree grow fast, and just makes art.
Wait, she's answering. That's cool.
That's like a cool crystal kit.
I would like to do something like that. We're going to be using crystals in lab today that you can actually use to grow amazing stuff with. And I'm going to show you guys a little bit of it because I read a whole article that blew my mind. It was so cool. All right. So if your endothermic reactions are are bringing in your heat and making it feel cold, your exothermic reactions are making it feel warm. So let me ask you, what is the main chemical reaction, do you know, that runs your body as far as energy goes for your cells? Do you know what that is?
Something.
Breathing is part of it. Yep. What's the word you use when you're talking about what's another word for breathing? A bigger, more scientific word. Can you think of one?
Inhaling action. No, that's not scientific enough.
You're getting closer. What do you call a doctor that helps people with breathing problems?
Job.
Or not really a doctor, but more like a therapist. Some kind of a therapist you might go to if you had bad asthma.
I forget, but
Physical?
Was okay. How about respiratory?
That makes sense.
All right, so check this out. When you breathe in and out, we call it respiration, right? But that's actually going on at the chemical level in every cell of your body.
I can only see the endothermic and
Your screen might be stuck. I'm gonna click one more ahead. I'm gonna click to there. We're not gonna
There.
answer this just yet. Hold on a sec. So anyway, respiration is going on in every single cell of your body, and it's called cellular respiration at that level. Go figure. It's also what we call an aerobic process, not like aerobics like, hey, let's work out, but that's where it gets its name from. Aerobic respiration, cellular respiration, is the exact opposite chemical reaction of photosynthesis. Flip-flop, totally the same, just flip-flopped. Which is interesting, right? Because what do we breathe out?
Carbon dioxide.
And what do trees breathe in?
Carbon dioxide.
And what do they breathe out?
Oxygen.
Okay, so it is the exact opposite chemical reaction. So let me ask you this. If your cells, every cell in your body, is going through the process of cellular aerobic respiration, which is that little process that's giving you energy, because the byproduct is going to be energy, are you an endothermic or an exothermic organism?
Both.
and both.
Feel yourself.
You're
Are you getting colder? Or are you producing heat?
producing
Yeah, you're producing heat. Right. Okay. So all those little tiny processes going in your body are all exothermic. When you exercise, do you get hotter or colder? Yeah,
Hotter.
because you're doing that reaction a whole lot more. Yep. So let's go through these answers real quick, and then we're going to go outside and do our little run of experiments, which should be interesting. Okay. So do you guys have this up? This is your notes. These are the answers for your notes.
yes.
You know the answer, wave at me. Any change that alters a substance without changing it into another substance is, yes, Ella. All right, very good. I'm gonna switch the camera so you can see. There we go. That's our physical change. Blank is anything that has mass and takes up space.
Matter.
Ella again. Oh, matter. Yeah, okay, Jocelyn said it too. Matter, very good. All right, how about number 9? A reaction that releases energy in the form of heat. One of you boys over there, Drew, what releases energy in the form of heat?
What releases energy?
It should be right there in your notes.
Exothermic.
No, releasing is exothermic. Right.
I guessed it.
It's in your notes.
He got me mixed up.
Yeah.
I told him the wrong answer.
Okay.
Yeah, no, that's why you got me.
So how about this one?
I pretended it was.
A blank reaction is a reaction in which energy is absorbed.
Endothermic.
There you go, Jocelyn, endothermic. All right. And a chemical change is also referred to as a what? Chemical reaction, says everybody.
Can you
Very
slow
good.
down?
Sure. And then our
I
last
spelled-
one is blank is a solid formed from liquid reactants during a chemical reaction. Ella, anybody else have it? Any of you girls? Okay, Ella, what is it? Yeah, precipitate specifically, but yes, a product. Precipitate is a product. Yep. All right. So here's what we're gonna do. Did you get all those, Sonia?
No.
Oh, okay. Hang on. Let me go back one more and let you look. I'll give you a second. Everybody can look and check real quick. Make sure you got them all. So what we're gonna do is we're gonna go out on the back deck, but all of you are gonna need to take eye protection and an apron with you and throw them on just in case you get.
I've got it now.
You don't need. Oh, there you go. You don't need your binders, just eye protection and an apron. Yes, did you have a question, Alec?
I have a completely random question.
Okay,
Do you bake with vanilla beans or vanilla extract?
depends. I do both.
Yeah.
Good, we got just enough time. We'll give you guys a second to copy that, get your stuff. Oh, you're good, you're good?
So I know vanilla beans are really good for some things.
Yeah, they are. It depends.
Yeah, that's just.
Okay, that one might be late later. Okay, so here we go.
This is exciting.
Let's bring us.
It's not nice that the tiny screen is the one that we're seeing.
Okay, I'm gonna bring both of these.
Hey,
up
Danny.
here. Yes, ma'am.
Could you maybe
They're
stop
Aprons are
sharing
right over here.
the picture?
Okay, what you asking me, Sonia?
I was wondering if maybe we could stop sharing screens.
Wait a
so
minute, y'all. I can't hear Sonia. Say it again, Sonia.
could we stop sharing screens so that like we could see the picture bigger? Because now it's just a tiny little like rectangle that we see.
I'm gonna bring the camera outside so you can see, okay? Does that
Okay.
help? Is that what you're asking? Hang on, y'all. Shh, everybody hush. Sonia's asking me something up there on the TV. See your face?
Right now it's like a tiny little rectangle that we can see of everything except for like the building vocabulary thing is what we can see.
Oh, yeah. I'm gonna make it
Yeah.
bigger because I'm gonna take it off screen share right now. See, and then
Okay.
it should go real
Okay.
big. Right there. Bigger?
Yay!
All right, so y'all do that. I'm gonna come back and grab my stuff. Okay, so we're gonna
That's a
set
cool camera holder.
one up far away, like here.
That's a cool camera holder.
And I'm gonna set one up
I like your new
closer
deck.
right here. And I'm
I
gonna
like
turn
your
this
new
camera
deck.
around. Get it
We like your
down.
deck.
All right, now I gotta go grab my stuff,
Miss
and then I will
Danny.
unveil the secret contents. Okay.
Danny,
Danny.
I like your deck.
All right, I gotta grab my stuff. Y'all
Nah. She can't hear us.
Senya,
Yeah.
I am an official Hufflepuff.
And I'm
Person.
gonna take those girls
I
off
took
the
like
screen
5
of the TV
different
because
Hogwarts
when they're
tests.
on the
I
TV.
still
We
have
can't hear them
Hufflepuff.
out here, so
I've- Two and one's
I'm gonna
Gryffindor and one's
disconnect them from that.
I've taken like 5 different tests, and every single time I got Hufflepuff. So I am an official Hufflepuff.
Ozzy was
Now we can hear them here.
literally enjoying all my pets I was giving him. He was like falling asleep.
Miss Danny,
Yes, ma'am.
He looks so
me and Senya like your new deck.
Thank you. I love my new deck,
wow, it's so
but we're not gonna mess it up.
Yeah, no.
Try not to.
That's
Y'all can
the
stand
word, try.
either
Try.
side of the table, and I'm gonna unveil what I have hiding under there.
Wait, what? Unveil.
Let me fix that. Yes.
Two
Why don't y'all stand kind of around?
Looks like Bunsen burners.
Okay, I'm gonna scoot it back this way a little bit though, because I want to get away from my computer.
Beakers. Chemical
Yes.
reaction.
What's under the white cloth?
Oh, we don't need it?
No, I know. Okay, so y'all can see that, right? Okay, good. Everybody can
Yeah.
see. All right, so.
Ooh.
First things first.
Why do we have a
Plastics.
Oh, we shall see.
Oh god.
So this represents
They have so many chemicals in them.
some kind of a chemical change. I've got, what do I have? 6 of these? I've got like 7 of you.
I'm
So
excited.
somebody share.
How to use them?
So what you do
My hands are
is
cold.
you, here's Sky, open that up.
I'll get one. Yeah.
We'll share it.
You gotta kind of rip it open.
You
get it?
expect me to open this one. I can't even open a fruit snack.
So you should be able to help.
I can't even open a fruit
should know
snack.
how to open these.
We put
Oh,
Are these? Yeah, these are hand warmers.
One time
Yeah.
I used a hand warmer because I
on.
still don't know how to open them.
Over here it says.
I get
Oh,
really.
look,
You can actually burn
tear along
yourself.
that top.
You
Tear
can
down.
burn yourself? No,
Yeah.
you can't. Oh, well, unless you
Now
yeah.
these.
I get like 130.
Okay,
You
there we go.
open the thing.
So here's what you do.
I like
You
it.
open
Don't
it up.
open it. Do not open this.
Listen.
Do not
Open up the package part, but not the little thing inside.
No, don't do that.
And
We're gonna
then-
use it for chemicals.
Listen, shake it
I can try to help.
because there are. Hang on, those aren't scissors. You need help?
I just need scissors.
So when you open it, listen. When you open it, it's gonna
There's a
cause.
little slit where you
Shake
pull
it.
down.
Shake it. It's gonna cause a chemical reaction
And then it'll become
with the air. And tell me what kind of reaction we're getting.
Heat.
Yeah, but what do we call that?
Are we gonna use this for something to make it actually?
No.
Are we just gonna have it?
Warming.
What endothermic? You're close. What's it gonna be?
Exothermic.
It's gonna be exothermic because they're warm. Anybody's warm yet? Get warm?
Oh yeah.
Mush it around and shake it.
Oh, it's getting a little
And
warm.
so,
Getting mine.
You can't see this reaction, but you can feel it.
I should know how to do these. We pack them for the homeless.
Yeah, there you go. Very cool.
Oh, there we go.
It's getting warm.
It'll take a bit.
Oh yeah. They're over there.
After like 15 minutes or so, we'll get hot.
So there you have.
This is about to burst open.
Now, can you think of a similar? Hang on, now. Can you think of a similar product that produces an endothermic reaction?
Microwave.
Microwave.
No.
No.
This is exothermic. Can you think of one that's endothermic?
What do you call it? Something with nervous.
Your body.
Sometimes they're in first aid kits.
Your own body. Band-Aid?
Oh, you ever held those cold packs?
Yeah.
You take it and then you pop it and you shake them around and they get really cold.
Oh yeah, I have those. I have those for dance.
You have those for dance? Those are really
Yeah.
cool.
Yeah, we have to shake, we have to like pop them and they make a really loud popping noise and then
Yes. You hear what Senya's saying?
then they're cold.
You guys hear what Senya's saying? For dance class, or dance lessons, they have, listen, they have these plastic bags and in them is another bag. And when you pop the internal bag, it causes the chemicals to mix and then it's an endothermic reaction. It gets really cold. And they use them for ice packs and you don't have to like keep them in the freezer because it's the reaction that makes them cold. So then if you think about popping and combining chemicals, hang on, don't beat it on the table because it's shaking them everywhere. What are these? Glow sticks. How do they work?
Don't break them open.
No.
You
Wait a minute.
crack them and they'll glow.
Hey, you crack them in the middle.
There's probably some kind of little
Yeah,
barrier in the middle that combines two liquids.
So there are multiple little barriers in here. And what it's
I've
doing,
opened that before.
Listen.
And it's gotten all over.
listen real closely.
That's
Listen,
dangerous.
listen.
It can kill
You hear it? So you're breaking open the little dividers that are keeping the two chemicals apart. Once they're together, what happens?
It makes it glow.
You get light. So when we talked about how your book doesn't talk about all the types of reactions, it didn't talk about light. So there's light. So you guys can try these and see how they
And if you crack them too hard, they'll explode and the chemicals will get everywhere.
You don't want to do that. And these are the little pieces.
It's
that-
happened to my friend. She's cracked a glow stick too hard and it exploded on her and got in her eye.
Not great, is it? That's never good.
No.
It's different.
Isn't it like
Mine isn't really.
Maybe you can't see it because you're outside and it's awfully bright.
It's blue.
But if I do like this, I can see.
Danny's looks really bright.
I'm gonna
Who's
break
this?
mine.
Whose looks bright? Jules?
Yours.
Danny's.
Oh yeah, mine. Mine looks bright.
Blood, yeah.
I need 2 jugs of fake blood.
Okay, so now,
Do I have a glow stick? Where's my glow stick?
are y'all listening? Are you listening, guys? You guys, chit chatty, chit chatty. All right, so now we're gonna do another one, and you guys are gonna tell me what this is.
Okay, yeah, that makes sense.
Trying to get it against a dark background so we can see. All right. So what we've got here is potassium. Stop eating it on the table, please. Potassium chloride. Okay. Alex. They're trying to listen. It gets really distracting when there's a lot of background noise. So this is potassium chloride, all right? And this is silver nitrate,
Oh.
all right? Whoops.
Combine them.
Right.
How big will it explode?
No, it's not going to explode. I'm going to bring it a little closer so they can see really well. Let me bring it down a little.
You wouldn't do any extra dangerous stuff.
There we go. All right, so if I take silver nitrate and I drop it into potassium chloride, are we all watching?
What? Oh.
Yeah.
Yeah.
Okay, what's that?
Ooh, bubbles.
Not bubbles, but if you,
Foam.
what is it?
Foam.
It formed something. It formed a precipitate. Do you see it in there? See how it's like
A
crystal?
precipitant called foam.
There you go. It's less
Exactly.
foamy and more. Now you can see it falling. Guys, stop beating on the table. It shakes their camera.
know it's wrapping around.
Now see it. Look. See how it's falling?
Yeah.
There you
That's so
go.
cool.
Isn't it cool? It's
Kind
actually,
of like
Ooh.
isn't that neat?
picnic lava lamps.
No, but it's a neat idea. Look at it pouring down in there.
It looks like a lava lamp.
It does.
Avalanche's name is kind of annoying. What are you doing?
Okay, so now we're gonna move on to another cool one. I need 2 volunteers. Who are my 2 volunteers?
Me and Cole.
Well, you've already done this one.
I did it.
How about
Oh, yeah.
Alec and Jules?
Yeah.
These are
All right,
fun.
so
Ready?
I'm gonna move my
Are you
little thing out of the way
I got my
here.
necklace. I'm ready.
These are called mask warmers now.
Hush, Drew.
Oh god. Yes, it's actually.
All right,
so put it
so-
outside or something? I only used 2. Why did you outside? But like put a second.
Okay, Alec, you gotta stop chatting on the side. You girls stop chatting on the side so that Alec, they can't hear if it's too much noise. All right, so I have 2 volunteers. Who are they?
And
Where am I going? It's always backwards in this camera. Okay, so hold on. Let me get these in the view. Okay, so Jules,
And
Alec. All right, now one of you has water and blue dye. One of you has water and a chemical indicator that designates acid. You're gonna blow when I say so, but wait.
No, don't drink it.
Wait.
I know.
don't drink it because you don't know whose is water and whose is.
Listen.
Don't
So
drink it.
One of you has a chemical indicator that will show you if there's acid present. Now, when you blow, what do we breathe out? Drew?
Carbon dioxide.
Carbon dioxide, right. So when you mix carbon dioxide and water, you produce,
have a chemical reaction.
yes, you're going to produce carbonic acid. And it's going to be really obvious which one of you has the acid and which one of you has plain water. So here's the trick. You got to blow slowly. Okay? So really slowly and gently. Don't drink it. Ready? 1, 2, 3. No, in it. Stick it inside, all the way in the bottom. All the way down and blow. Oh, don't pull it too far. There we go. We can't see it. There we go. Blow, blow, blow. Keep blowing. Really gently. Keep blowing.
She's doing fun.
She's doing good. Let's see.
going to a mask.
You can take your mask off to blow, silly. Ah, something's happening.
Alex is changing.
What's happening here?
Yeah,
Keep blowing, Alec.
The acid in it.
Oh, the one of them is turning green.
That sure is. So who had the
The
water?
other's about to blow up and go all
You
over
just
the
had the
side.
water, Jules. What does Alec have? Alec has
It's turning yellow now.
that.
Yellow. Did you just suck
No.
A very weird yellow color.
Good job.
if you drink
Hooray!
acid in our stomach?
So all we got,
What the heck is wrong?
he didn't suck it up. He
I
did
trusted
it.
her to make sure it was safe because you know.
No sucking. We just blow. So yeah, so he got, this was, whoop. Isn't that wild? And if he were to continue, it would go totally yellow instead of that greenish yellow. All right, now we have one more.
Oh,
These are fun little flasks.
I volunteer to be.
There's some weird little glass.
All right, let me move a couple things around. Back a little bit. These are fun, aren't they? These are cool flasks. Okay, so I'm gonna need 2 more volunteers, and the trick is,
2 to 1 huge explosion.
you're gonna have to be able to pour and move quickly. So
What's in here?
Ella wants to do.
Uh-oh.
Okay, so this, I'm
It's
gonna
gonna explode.
this
It's gonna
At least it isn't gonna be as big as an experiment with this mixture, and it's on Emily's Wonder Lab. It's really cool, and it goes like.
Okay, and what you're smelling is the yeast.
Oh yes.
The reaction that the yeast makes.
What is yeast?
So yeast,
Listen.
yeast is actually a fungus,
Yes.
but it eats.
Yoda is
No
too.
joke. If you're listening, you listening?
Yes.
It eats sugar, and then it kind of burps out gas. And when it does that, it smells, but it also makes your bread rise.
Oh,
Yeah.
I use it in pizza too. It's
So,
not too tiny instead.
Weird.
Who's doing? Okay, so you're gonna go over here, and Ella, you're gonna go over here. And what did I say was in yeast earlier? Did you hear me?
Fungus.
Let me stand right here where you are, Jules. I said it had catalase in it, which makes reactions go faster. All right, so let's see. We got Lily. Ellie, you step right on that side.
You just heat it in there.
On the count of 3, we're gonna pour it. Ready? 1, 2, 3, 4. Pour.
It doesn't really do anything.
Wait.
Oh gosh.
Oh,
That's cool.
oh my goodness.
Wow.
That's cool.
I put a hot topic
That's pretty cool. So I added a little dye. So you can,
Pink. And one turned green.
yeah, well,
Pink.
actually, I put, it's the same kind of idea.
She won't let us because apparently it's too hot. She's actually just.
So listen, are we listening?
Yes.
So this is the same idea as the elephant toothpaste, but not quite as reactive.
Elephant toothpaste will. It would much more big.
I put, listen, are we listening? I put color in there so that you could see it better. But what was in the flask to begin with, and it's still going, I don't know if you girls can see it, but
Smells
it's
like
still
dish soap.
oozing, is dish soap. Yeah, there's dish soap in there. And why do you think I put dish soap in there?
Is it hot?
Yeah,
So it fizz
For
up.
the bubbles.
right. If I didn't put the dish soap, you would see the bubbles, but it wouldn't be quite as dramatic, would it?
They keep going.
No, it
Allow
wouldn't.
you to continue to see it.
It's like elephant.
So, does anybody know what was in the flask to begin with?
Water.
Peroxide.
Yeah, makes sense.
Hydrogen peroxide. So hydrogen peroxide breaks down, and when it does, it turns into oxygen and hydrogen.
I like this.
And the yeast has the catalyst in it, which makes that happen really fast. So if we didn't use the soap, you would get bubbles, but they wouldn't last. It would make a foam. And this is really kind of
Is
fun.
it hot?
Now, that's the next thing I was going to say is if you touch, you should feel a little warm. Do you feel a little warm? It is an no, down in the bottom. It is an exothermic reaction. It's a tiny bit warm. A little warm.
It's thing.
Pretty cool.
So it's basically just soap now.
Here, you can wipe your hands on the rag. Yeah, it's just soapy water as it's coming off. Pretty cool though. Look at that.
Wipes it off.
Do they take- or
Does
touch
it mean
it?
it'll explode?
It looks like cotton candy.
Cool.
I
So-
so, eat it.
It
Kind
looks
of.
like cotton candy.
Okay, so listen.
What is with you?
Cherry deflated cotton candy.
Yes, are we listening? So now it's time for us to go in and do lab. Now, you two girls, lab
Yes.
for you is going to be out probably tomorrow by noon. I'm actually going to film today during lab. I've already done all the background stuff, but the actual filming of the reactions and the process is going to happen in lab today. So don't look for it tonight, but I'll tell everybody when it's out. Okay?
Okay.
All right. Y'all tell Senya and Jocelyn later.
Watch the video at any time.
Bye.
Bye. See you later.
Most available at 1 a.m. maybe.
Yeah, get up.
Chug it.